Hey everyone, and welcome to this visual guide. Look, if you're a solo developer or an indie hacker, you already know the incredible promise of AI agents, right? But you probably also know the harsh reality of those frustrating late-night coding sessions. You know the drill. You spend hours building an agent to extract data, process it all, and send it straight to your database. You hit play, the logs light up green with that beautiful task complete message. But then, when you go to check the database, man, it's completely empty. There's no 500 error, no stack trace, just nothing. Well, today we're going to dive into a logical roadmap to stop wasting time, eliminate these silent failures once and for all, and build workflows that actually work. So let's look at our agenda for today. First, we'll cover the danger of silent failures. Second, thinking like distributed systems. Third, step-by-step validation. Fourth, orchestration and critical alerts. Fifth, the top 5 silent failures. And finally, monitoring and keeping costs affordable. Let's get right into it.
All right, starting with section 1, the danger of silent failures, debugging the invisible.
Take a look at this real quote we pulled from Reddit. The user asks, how do you debug silence? It's a completely universal experience, and honestly, it creates massive mental overload for anyone working alone. It is so important to understand that this isn't a lack of coding skill on your part. What's actually happening here is an architectural flaw in how we've all been taught to interact with large language models. To understand this better, a silent failure happens because LLMs are fundamentally probabilistic. They are trained to be helpful at all costs. So if an API fails or times out, what does the agent do? It just fills in the blank. It confidently hallucinates a response and continues the process like nothing happened, leaving absolutely zero trace or those 500 errors that we developers are so used to looking for. And this MIT data illustrates the real-world impact perfectly. Did you know that only 5% of AI pilot programs achieve rapid revenue acceleration? Meanwhile, a staggering 95% end up completely stalled. And get this, these projects aren't failing because of bad ideas. They fail because of invisible integration gaps, weak retry logic, and these silent failures that quietly ripple through the whole system.
Which brings us to section 2, thinking like distributed systems. You are not building a chatbot.
Notice the massive difference in architecture here. The chatbot approach relies on trying to fix everything just by tweaking prompts, assuming the execution is always going to be deterministic. But the real world of AI demands a distributed system approach. Think of it like the electrical wiring in your house. You don't see the wires inside the walls, but it's those invisible safety breakers that prevent the whole grid from short-circuiting. That is exactly why solo developers need to build a robust 4-layer architecture. Because look at what happens without those safety breakers. We end up with confident hallucinations. The agent just makes up data out of thin air when something goes wrong. The harsh truth is, we can no longer just trust a green task complete message. We need verified outputs, cross-referencing what the agent says with live web sources before we send anything to our database. Let's move into section 3, validation step-by-step, the reality check layer. So how do we actually implement this validation layer? Here is our logical step-by-step roadmap to eliminate wasted time. Step 1, you extract the source URLs right from the agent's output. Step 2, use an amazing tool like Firecrawl to cross-reference the data dynamically. Firecrawl actually converts heavy JavaScript-rendered sites into clean Markdown so you can verify facts in real time. And Step 3, score the confidence before writing anything to the database. Check out this practical example of a trust test. We route the raw agent output to a blazing fast model, like GPT-4o Mini, which acts as a strict quality gate here. It generates a simple JSON with a confidence score from 0 to 1 and a clear routing action. If the score is high, like 0.9, it's approved instantly. If it's borderline, it goes to manual review. And if it's useless, it gets totally rejected on the spot. And if you're a solo dev looking to keep your stock affordable, write these tools down because they are game changers. Perplexity Pro is a stellar citation engine for catching fake stats. Firecrawl, as we mentioned, is perfect for dynamic web scraping. And GPT-4o Mini, man, it costs fractions of a penny per validation call. That gives you extreme ROI and completely eliminates those hours of mental overload from debugging bad data. Moving right along, section 4, orchestration and critical alerts, your pipeline's nervous system. To tie all this together, visual builders like Make.com are absolutely fantastic. You know why? Because they handle those annoying rate limit errors automatically through exponential back-off retries. Like if an API drops, Make just waits a bit and tries again on its own.
Plus, we can use webhooks to route sketchy outputs straight to a manual queue and integrate critical failure alerts with tools like Form Carry. This creates a fully automated safety net so you don't have to constantly babysit the system. Speaking of real-world infrastructure errors, have you ever seen those amnesia agents that get stuck in an infinite loop? They just endlessly scrape the exact same pages all night long, racking up a massive API bill without giving you any new data. The solution to prioritize safety here is implementing idempotent agents. You add state persistence using tools like your AI agent, or even just a simple Redis deduplication hash to give your agent a memory. Let's dive into Section 5, the 5 silent failures, what's really breaking your pipeline. To help you identify these errors before they steal your valuable time, here's a quick list of the top 5 deadliest silent failures. 1. Tool error fabrication. That's when the agent hits a limit, hides the error, and invents data. 2. Context truncation drift, when you send super long inputs and they get silently cut off. 3. Infinite loop scraping, which we just talked about. 4. Semantic drift on handoff, which is when one agent passes data to another and the context gets lost, like a game of telephone. And 5. Sycophantic confirmation. That's when the agent just tells you what it thinks you want to hear instead of the truth. Definitely watch out for these. And finally, Section 6, monitoring and affordable costs. Building the stack for under $80 a month. So to avoid that extreme fatigue of hunting for errors and endless text logs, here's a great trick. Use Bolt.new to create real-time monitoring dashboards. You literally just describe the interface you want, and Bolt generates a production-ready dashboard in minutes. It's awesome. It cuts front-end dev time by like 60%, allowing you to visually spot failures instantly, way before you even need to open a log file. And the best part? This entire distributed ecosystem is super accessible for beginners. Make.com costs around $9. Replit for a stable code environment is $20. Perplexity Pro is another $20. Add in some basic web hosting on Hostinger and pay-as-you-go fees for Firecrawl, and your total comes to between $65 and $80 a month. That gives you real enterprise-grade durability, but fits perfectly right into an indie hacker's budget. Well, to wrap up this explainer, I want to leave you with this challenge. Please do not keep debugging in the dark until 3 a.m. Which silent failure are you going to eliminate from your workflow today? Take that one agent that gives you the biggest headache, start small, add just one confidence test layer with GPT-4o Mini, and man, get your weekends back. Thank you so much for joining me today, and happy building to all of you.